With this, we conclude this presentation. So we so far presented a background subtraction based on an adaptive Gaussian mixture model for the segmentation of moving objects and random decision forest for contour segmentation. This proposal improved the original Gaussian mixture model by preserving the contours of objects and allows the adaptation of number of Gaussians. This proposal enhances the result of motion-based classification, since in our approach, our descriptor, our focus is on contours of the shape. The second contribution deals with the convolution-based descriptor. As explained, small curvatures or small articulations of shapes are detected in the early stages of convolution. Large curvatures are preserved up to high Laplacian of Gaussian filters. The variance of the filter makes it possible to detect the radius of the curvature. Our third contribution is to track moving objects based on their articulated motion. Indeed, an object is tracked by tracking all its key points detected using our descriptor. The approach allows for trajectory generation using graph theory. This contribution handles cases of fragmentation and merging, present in most tracking situations. Lastly, we solve the main problem of this thesis, the classification of moving objects in low-resolution videos. In this part also, we contribute by applying our algorithm based on bag of words for our descriptor quantization and compare it to a bench of other descriptors. We use, moreover, a set of classifiers, KNN, neural networks, and support vector machines, and a set of entries, full moving object with background removed, and fragments of moving objects. For each case, we present and analyze the obtained result, and the approaches we propose were evaluated on international benchmarks of binary shapes and video sequences. We presented a comparison of our approaches to those of the state-of-the-art and criticized the obtained results in this thesis. As a perspective, we would like to do the following. Apply a quantitative analysis and compare to recent state-of-the-art approaches, especially those known in LLS libraries or PGS libraries. In the tracking phase, we would like to add graph analysis in order to have correct trajectories of moving objects, even when they merge or they split. And the third contribution is in the feature selection. So recall that we didn't use inner distance, shape context, and height function because of the high dimensionality. We would like to apply a feature selection in order to reduce the dimensionality of these features, and so analyze them in the case of videos, which really require wait time. And finally, we would like to analyze deep learning algorithms, in this case, such as convolutional neural networks, or even recurrent neural networks, since we are in videos, in order to position our work with those algorithms. With this, I conclude this presentation. These are references used in the presentation. And this is the list of our publications. And thank you for your attention.